Okay, hello there. So it's time to inspect the executable file that we found in this interesting out of the ordinary directory in our C drive in the libdc domain controller. So in order to further see what it does and how we can manipulate it, we transfer it to a Windows machine, and right now we're going to inspect it a bit. Now, interestingly enough, and sorry if my machine is a bit slow. I think it's updating right now. So interestingly enough, we found one article about DLL hijacking for this specific tool here. Okay, if you hear him meowing, it's my cat. And there are other articles about it as well. It's a really interesting walkthrough. So we're going to, uh, you know, simulate the exact same steps to inspect how this executable works and how we can manipulate it. Okay, so we use Procmon, Process Monitor from sysinternals. It's a great tool to find processes created by the system, by various programs running. Um, and as you can see, we already have tons, literally tons of processes here. We have Windows processes, we have the OBS processes because we are recording right now, but we really want to focus on this tool. So a way to do it is use filters. Okay, so the first filter I'm going to use is the process name to contain the Kaspersky uh, removal tool, and we're going to add this rule. And we press apply here. You can see that we see no more processes anymore because obviously the tool is not running right now. Now, since we are interested in DLL hijacking, we also want the path to contain the DLL extension. Okay, so we're going to add this rule as well. And I think we're good for now. Let's try to launch the tool. Okay, let's accept the end user license agreement. And let's leave it in the background. As you can see, we have literally a lot of processes running. Okay, so you can see that when you run a program, lots of different things are happening in the background, all right, things that you cannot see. So all those processes are related to DLLs. Okay, if we hadn't filtered for DLLs, we would get even more. Now there are many interesting things here, but what we want to do is actually find a DLL that we can manipulate. And what we should focus is the name not found result. This means that when the tool runs, it actually tries to find some DLLs to utilize them. Okay, and if it doesn't find them, it can, maybe throw an error, or it will try in that case to create them. So we can see here that it searches for the msls31.dll, and since it does not find it, it creates it in this very specific path. Now, the path here is important because we should notice what path is used to call the DLL and what path is used to create the DLL if it's not found. And here we have the tool in our desktop, and as you can see, and as you can see, this is created in the same directory as our executable. So in order to be able to better look at it, okay, let's also filter further. All right, so the result is name, I'm sorry, not found. Okay, so let's add this filter, let's press apply, and here our results are significantly increased. Okay, so we have those DLLs, all of them cannot be found, and as you can see, all of them are created. So what we can do right now is try to create a malicious DLL with MSF Venom, okay, and place them in a directory where they're being called and created. And when we run the Kaspersky removal tool, the tool will search for those DLLs, but this time it will find them. Okay, it will find one of them, the one that will try to hijack. And since this is a maliciously crafted DLL, it will give us a reverse shell backdoor machine. And if everything goes well, this reverse shell will be with administrative rights. It will be with system rights because, as you remember, the tool is running with administrative rights. Okay, so we can start experimenting here. We can take note of all those DLL names here and try them one by one. Of course, mind you that experimenting might actually break something, so it's better to try and test it locally before launching it to your target. Furthermore, you can inspect some properties of the event or some properties of this specific process here. Okay, for example, we are very interested in the architecture, the parent ID, and we can also find interesting information about modules here. Of course, the path is extremely important, as we mentioned before, because if we hijack the correct DLL, but we don't, um, if we don't place it in the right directory, then we'll have a problem. All right, the integrity here is also important. Okay, a high integrity means that we're running with administrative rights. So let's go back to our attack machine, all right, having noted those names here. And let's try to hijack one of those DLLs in order to get a shell back to our system as system. All right, thanks for watching. Let's jump to the next video.